When we look at enlargements, we ask ourselves, how much bigger did the shape get? So how much bigger did this little grey triangle get when it became this big black one? So we enlarge something by a scale factor, and when we do that, we times it by a certain number. Every side of this shape has been times by the same number, and that is what made it bigger. So when I look at this little, I had 2. Can you see there? The length is 2 blocks. The new length is how many blocks? 4. What do I do with 2 to get a 4? I times it by 2. Now, to make sure that that works, I want to try another side and see if the other side was also times by 2. But do you agree with me that it's difficult to measure these sides? I just want to use another color to show you. These sides are so difficult to count on these blocks, aren't they? Because they go through half and quarter blocks and things. Don't ever try and count sides like that. Okay. I want to show you a trick, and you have to use this trick when you need it. Why don't we then just look at how high the triangle is? So let me erase what I did there, and let me quickly. How high is this triangle? 1.5. It's 1.5. Okay. How high is the new triangle?
3 blocks.
It's 3 blocks. Can you see it goes from block number 4 to block number 7, so you can even work it out. So that's 3 blocks. How can I get a 1.5 to turn into a 3? I times it by 2. This is proof. The fact that 2 parts of my shape was times by 2 is proof that everything was times by 2. So now you need to learn this word. The new word you're looking for, and highlight that on your page, is scale factor. And the scale factor is what I timesed or divided by. It's actually not divided. I'll show you now how we write instead of dividing. But we timesed by 2 in this case. To draw these, you're going to find it easier, once again, like I showed you, to go with straight sides, vertical or horizontal. Don't try and count or measure anything that goes through blocks like that, because you're going to end up miscounting. Okay. For now, I'll always give the pictures to you on a grid if I want you to count, or I'll give you their side lengths. Okay. Just another term you need to know. The light blue, this one they're saying it's light blue, but it's grey. This is called the object. You know, an object is a thing. And then the new one is called the image. Once it has grown, it's called the image. You kind of need to keep that in mind, because you always need to, if you don't know which one came first, you're not going to know whether it enlarged or whether it reduced. Do you understand? If you think the black one came first, then this would have been a reduction. Hey. So just keep in mind, when I tell you which one is the object, that's the one that came first. Next page. One. Okay. What's the scale factor here? Let's look at these. Now, these are not on grid, but I do have measurements that I can easily quickly work out. This one went from a 10 to a 40. Now, remember, it's not about how much you plus or minus. You can't do that. You have to look how much you times it by. How can I turn a 10 into a 40? Times by 4. And so the scale factor, I just need to zoom out there. The scale factor here is that to go from a 10 to a 40, I must times by 4, so I have a scale factor of 4. There's your answer. Now they use the same example, but they say, what's the length of the side marked X? And this is quite easy to figure out because I know that the 10 turned into a 40 by timesing by 4. So if this was 2, then what would x be? This side would be 2 times 4, which would be 8. We're going to do the same with triangles. If we look at this guy that has a 7, what's the scale factor? How can I go from a 7 to a 42? Let me show you. Do you remember inverse? You can just use inverse. You can say, okay, if you're going to say 7 times what is 42, then you can just as well go do 42 divided by 7. So often just doing a normal divide sum will give you your scale factor. Not often, always. So what is 42 divided by 7?
6.
So I have 6 as my scale factor. Now that I have a scale factor, I can work the next one out. What's the length of the one marked x? So if I look at that one, I don't know yet, but I do know that I was timesing by 6. So 2 times 6. So it'll have to be 12. This is easy, hey? Okay, what becomes a little bit more enjoyable is when you have to actually draw them yourselves, and when you draw them on grid paper. Remember, you must always use a ruler. Now they say enlarge the shape using a scale factor 2. They stick to the boring little old 2. Now none of the lengths are given, but you can see them by counting. Now which two sides, no, let me rather ask this. How many sides can we count on this one? There's this one. I can definitely count this one. But further, the other two are not vertical or horizontal, so they're going to be difficult to count. But I'm going to show you another way to do it. Okay, but let's first start with this guy. Let's enlarge it by a scale factor of 2. How long was this? 1, 2, 3, 4, 5, 6. So I now need one that is how long? 12. So my new one is going to have a line of 12 here. Okay. Before I draw, let's now check how I can figure out the other points. That red corner or angle. Let's quickly count vertical and horizontally where it is. It's 1, 2, 3, 4, 5, 6 down and 1, 2 to the right. Let me just times those two numbers by 2. So instead of a 2 here, if I do a 4 from there, and I do, what was this now? 6. So I do 12 from there. Then I can find where that dot needs to be, and I can connect the two. And that should give me enough to draw. Okay, let me try that. So, red one, no, let's start with the blue one. I know I need enough space to have about 12 up, so I need to just count that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I draw about here, I should be fine. Here. 1, let me just estimate again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll be fine. Okay. So I'm going to draw this 12. I don't really have a way of drawing straight lines, but I can try. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. And now, to draw the other angle, I'm going to count 4 blocks to the left from here. 1, 2, 3, 4, and then I'm going to go 12 up. 1, 2, 3, 4, 5, 10, 11, 12. Okay. Why am I not drawing those lines? Because that's not really part of my shape, but at least I have now found that angle. Let's see if I can do this. I doubt it. No, that's not going to work. Okay, I'm going to have to draw this without a ruler, but I'll try and get it as straight as possible. You use a ruler. There we go. Do I need to measure the other side and double it and all of it? No. If you've done 2 out of the 3, you're fine. So now all I need to do is take my ruler and connect these, and I know that this has also enlarged by 2. So I knew this had to be 12, and instead of trying to measure out a side that has no weird lengths, I went 2 became, this 2 became a 4, and that 6 became a 12, so a 4 by 12, 4 to the left, 12 up, and I found my new. So again, it comes down to going from angle to angle. Now, let's look at reducing. Reducing works exactly the same, except for when they give you the scale factor, they will talk about a scale factor of a half. So, guess what that means? A scale factor of a half means go and divide by 2 instead of timesing by 2. So, guess what a scale factor of 4, if I want to reduce it by 4, what would I do? I would say enlarge this by a scale factor of a quarter, which means I'm going to divide by each side by 4. Okay, so the fractions are not going to scare you. Scale factor 2 means times by 2. Scale factor half means divide by 2. Scale factor 4 means times by 4. Scale factor quarter means divide by 4. Okay, and this one we're just going to half. We're going to enlarge it by a scale factor of a half. That's why we don't say reduce or enlarge. We just say enlarge it by a scale factor of a half. Or it doesn't really matter what you say because you're going to divide by 2. Okay, so you can see 6 became 3, 4 became 2, and 6 became 3. Did I bother to count that side? Nope, no need to count it, because once I drew those 3, I could just connect those 2 dots, and it did pan out the right way. So I keep avoiding the sides that I'm not able to count. Okay, I just want to you now we can do one of these. So they say enlarge this shape by using a scale factor of a half. Do you see they're saying enlarge, but it is now going to get smaller because I'm going to have to divide by 2. So which sides would I like to avoid? Those 2. Hey, I don't feel like counting them. I can't count them. But what I will look at is that angle. Let's start with the other side of the arrow. And we'll start here. This was a 2. Now it will become a 1. Okay, that's cool. This was 1, 2, 3, 4. 1, 2, 3, 4. So that will become 1, 2, 1, 2, because I'm halving them. This was a 2. That was 2. So they will now each be 1, 1. I don't want to count these 2 sides out, but what I can do is just say, from here, let me make a point there, from there, how many lines was there? 1, 2, 3, 4. So mine now has to be 2. 1, 2. There you go. And it has to be right in the middle, obviously. So now I've got it. Now I can just connect them. There to there, and there to there. So I have not counted those diagonal sides, but I have actually used a little trick of just counting inside